A pleasant good afternoon to everyone. On behalf of my co-authors, allow me to present our study entitled Hydrophobic Anti-corrosion Coatings for Steel Plates using Nanosilica modified with Hexamethyldisilazane. For the introduction, the steel industry is a basic prerequisite in a country's pursuit of development and industrialization because of its central role that stems from its linkages with numerous sectors. The products of the steel industry serve as essential inputs to countless uses in several applications such as construction industry, infrastructure, automotive industry, electronics, shipbuilding and repair, and household development. Steel is used in the infrastructure industry, and in 2014, the Philippines consumed 6.6 million metric tons of it. One of the causes of steel deterioration is corrosion. According to the Intech annual report in 2014, corrosion caused an average loss of up to 3.5% share of the country's gross domestic product. The corrosion of steel structures is a common problem in everyday life. It is one of the predominant causes of destruction and loss of material due to the damages it can bring to operating, storage, and structural equipment. The negative impact of corrosion motivated the scientists and steel manufacturers to develop ways to inhibit corrosion. This led to the development of chromate and lead-based corrosion inhibitors, which are widely used today. However, corrosion inhibitors come in the form of paints. A large percent of commercially available paints have lead contents that exceed the 90 ppm threshold value. This led to the development of alternative anti-corrosion products like the silicate coatings. In this study, the development of silicate coating utilizes nanosilica from rice hull ash. This nanosilica has been reported to fill in the very small crevices on the surface of metals. Thus, it can be the main ingredient for developing a silicate coating to prevent corrosion. In addition, in order to develop an effective coating with nanosilica against corrosion, the coating has to be hydrophobic. In this study, hexamethyldisilazane was used for surface functionalization of nanosilica. The methodology to develop the nanosilica coatings starts with the preparation of nanosilica from RHA. This nanosilica came from the hydrothermal nanosilica, which is a product of the proprietary technology of the UPLB nanotechnology sub-program for engineering applications. Dynamic light scattering and X-ray diffraction analysis were used to characterize the obtained RHA nanosilica. The obtained RHA nanosilica powder was converted into a silicate coating that was applied to the steel samples using successive ionic layer adsorption and reaction method, or SILAR. Conversion coating was another type of coating that was developed using sodium silicate and colloidal nanosilica. This formulation was applied to the steel samples using dip coating with ultrasonication. Electrochemical impedance spectroscopy was used to determine the total impedance of the coatings. Silver chloride was used as reference electrode, while stainless steel was used as counter electrode. The cell setup shown here was then connected to an impedance analyzer. A software Nova 2.1.4 was used to analyze the impedance data. For the results, the characterization showed that the nanosilica was amorphous with a polydispersity index or PDI of 0.366 plus or minus 0.1443 and a hydrodynamic diameter of 17.817 plus or minus 0.7894 nanometers. On the left-hand side of this slide, the specimen coated using the Siler technique is shown, while the specimen using the conversion coating is shown on the right-hand side. There were three formulas developed under the Siler treatment of application. One of the formulas developed reached around 250,000 ohms of total impedance. This was marked as the optimum formula under Siler. On the other hand, two of the formulas developed using conversion coating reached around 2 million ohms. The formula with a higher total impedance was marked as the optimum formula under conversion coating group. Another way to present the impedance performance is to look at the resulting Bode plot. From the plot, impedances from the optimum formula both for Siler and conversion coating showed higher performance compared to bare steel. Conversion coating show even higher impedances by 2 orders in magnitude at the low frequency region. Both optimum coating formulations developed using Siler and conversion coating were found to be hydrophobic, as shown by the high contact angles, higher than 90 degrees. To summarize, two new silicate-based hydrophobic coatings were developed and optimized to inhibit corrosion on steel plates. Silicate coating applied using the Siler method and silicate conversion coating applied using deep coating method. The coatings were primarily derived from the RHA nanosilica produced using the proprietary technology of the UPLB nanotechnology subprogram for engineering applications. The performance of the developed coatings were analyzed using electrochemical impedance spectroscopy and water contact angle analysis. It was found out that the optimum formulation using the deep coating method exhibited the highest impedance readings among the coatings being developed. Both the WCA and EIS analysis results indicate that the HMDS modified nanosilica coating yielded an improved corrosion protection for stainless steel plates. This study is part of a project funded by the Philippine Council for Industry, Energy, and Emerging Technology Research and Development, or PSERD of DOST. The team is composed of personnel who are chemists and engineers. This ends my presentation. Thank you very much for your kind attention.